Hi folks, Mrs. Gates here. Today we are going to be talking about various types of forces. My goal is for us to develop some common vocabulary as we talk about forces acting on objects, and to develop some diagrams that will help us understand how forces interact with the world around us. The first thing I would like you to do is consider the picture that's shown here. Take a minute and make a list of as many forces as you can that are acting in this picture. Before we discuss particular forces, let's review what we mean by a force. Recall that our working definition of a force is that it is an interaction between two objects, and that interaction has the potential to change their momentums. The variable that we will typically use for a force is the capital letter F. We will often add a subscript to indicate what type of force we are talking about. And the SI unit for a force is the Newton, named after Sir Isaac Newton. Take a second and look at the list of forces you made. Do they meet that definition of being an interaction between two objects? The first force we will consider is the gravitational force. This is the same force that pulls objects down out of trees and that keeps planets and moons in orbit. When do we see the gravitational force? We see a gravitational force whenever we are near a large object, a planet, a star, the Milky Way galaxy. If you think about the direction that a gravitational force will pull, it is always pulling towards the center of the large object. The symbol we typically use to refer to a gravitational force is a capital F with a subscript G for gravity. Sometimes the gravitational force on an object is called the object's weight. Is this a contact force? Well, the moon is not in contact with the Earth, yet it still feels the gravitational pull. Therefore, gravity is not a contact force. If we consider the diagram you examined at first, we may need to zoom out just a bit to see the gravitational force. This is better. The gravitational force between the Earth and the car can be represented by arrows pulling both downwards on the car and up on the Earth. The next force we'll talk about is called the normal force. Normal is the old-fashioned mathematical term that means perpendicular, and we'll talk about why in just a second. This is probably a force that you mostly take for granted. A normal force is simply the force of a surface pushing up on something. You can picture this by imagining yourself jumping on a trampoline. Every time you land on the trampoline, you can feel that surface pushing you up and springing you back up into the air. On the very tiny level, this is basically the molecules of one surface repelling the molecules of the other surface. The direction of the normal force is always perpendicular to the surface that's applying the force. That's why it's called the normal force. If you are jumping on a trampoline, the normal force is pointed straight up in the air. But if you picture the child sitting on the slide, the normal force will be perpendicular to the surface of the slide. That means that the force on that boy will be slightly up and slightly to the left. The symbol we use to represent the normal force is a capital F with a subscript N. You'll sometimes see just the capital N used to mean the normal force, but this can get confusing since the unit for force is also capital N for Newton. Is this a contact force? Yes, the normal force is a contact force and is usually a compressing sort of force. If we consider the image that we looked at the beginning and look at the normal force between the car and the ground, we will first need to notice the direction the ground is sloping. The normal force of the ground pushing on the car will be perpendicular to this line, meaning that the normal force on the ground will be slightly up and to the right. The car is also pushing down on the ground, exerting a force on the ground that is down and slightly to the left. The third type of force we will consider today is the frictional force. This is the resistive force of one object rubbing against another. There are two forms of friction, moving or kinetic friction, and not moving or static friction. We'll consider those both more in depth in a few days. When do we see friction occurring? Anytime a surface is being sheared. The direction of friction is always parallel to the direction of the surfaces that are in contact. The symbol we most often use for the force of friction is a capital F with a subscript FR. And this is definitely a contact shearing force. If we consider the first diagram we looked at, we will need to zoom in just a little bit to see the force of friction. Let's look at the force of friction between the man's foot and the ground. Notice that the ground is drawn in here with a black line. The force exerted by the ground on the man's foot is parallel to the ground and pushing forward. The man's foot is also pushing on the ground in a direction that is parallel to the ground but moving backwards. The last type of force that we will look at today is the force of tension. Tension occurs when a rope is pulled taut. The direction that tension acts is always along the direction of the rope. The tug-of-war team here is exerting a tension that is along the direction of the rope. And if you have been camping and suspended your food to keep it away from bears, the tension in the rope is always pulling in the direction of the ropes. The symbol we typically use for tension is a capital F with a subscript T. Occasionally, we will use just a capital letter T. Tension is a contact force. It's an extension contact force. If we consider the diagram we looked at the beginning, in order to see a force of tension, we're going to have to go inside of the car. Let's imagine that the car has a pair of fuzzy dice hanging from the mirror. There is tension in the cords connecting the dice to the rear view mirror because they are pulled taut. The direction of the force pulling down on the mirror from tension is along the direction of the rope, and the tension is pulling up on the dice in the direction parallel to the rope as well. Remember our definition that the force is always an interaction between two objects? Let's look at how we might identify forces, and then we'll do some practice. When we identify a force, it's always a good idea to list the type of force and the two objects it is acting on. For example, we might say there is a gravitational force that is acting between the earth and the car. Let's practice identifying forces on the diagram below. See if you can list 3 forces that are acting. Identify the type of force and the 2 objects that are interacting in each case. There are many forces you may have identified in this image. Here are some of the ones you may have written down. There's a gravitational force between the earth and the man, and there's a gravitational force between the earth and the box. There's a push force, which is another kind of normal force that is being exerted between the man and the box. There is a frictional force between the floor and the man's foot. There's a frictional force between the floor and the box. There is a normal force acting between the floor and the man, and there's a normal force acting between the floor and the box. In physics, we will often view phenomena from the level of a system. A system simply means taking into account all of the objects that are involved. If you consider the forces we just talked about, all of them involved the same 4 objects: the earth, the man, the box, and the floor. In order to depict what's going on with these forces, we will sometimes employ something called an interaction diagram. An interaction diagram is simply a diagram which lists all the objects in your system and connects them with lines that represent the forces. For example, there is a force of gravity between the earth and the man, between the earth and the box, and between the earth and the floor. There is a normal force or a push force of the man pushing on the box, and there is a normal force between the box and the floor. There is also a force of friction between the floor and the box, and a force of friction between the floor and the man's feet. Notice that each of these lines is connected to two different objects, indicating the two objects which are interacting. Let's practice again by looking at a new system. Let's consider a textbook that weighs 20 newtons. That means the force of gravity on the textbook is 20 newtons. It is being pushed upwards against the ceiling with a force of 25 newtons. If you consider the objects that are involved, we have a book, a person, the ceiling, the earth, and the floor. Take a second and on a sheet of paper, draw an interaction diagram showing all of the forces in this system. Your interaction diagram for this situation hopefully looked something like this. All four objects are listed here. Notice that the Earth is exerting a gravitational force on all of these objects, and that there is a normal force acting between each object. There's a normal force between the book and the ceiling, a normal force between the person and the book, and a normal force between the floor and the person. Sometimes, as we analyze phenomena, we will want to focus on one object instead of the system as a whole. In this case, we will draw what we call a free body diagram or a force diagram. This diagram will show all of the forces acting on one particular object and represent the forces as arrows. The arrows will point in the direction the force is pulling or pushing on our object, and the length of the arrow represents the magnitude or the strength of the force. If we were to consider this interaction diagram, but focus on just the forces acting on the book, we would draw a free body diagram that looks something like what's on the left. On the book, there is an upwards normal force from the man's hand of 25 newtons. The book weighs 20 newtons, which means the downwards force of gravity on the book is 20 newtons. And there is also a normal force from the ceiling on the book. Since the ceiling is above the book, it is pushing down on the book, and we've drawn that force in as Fn from the ceiling with an arrow going down. These forces are not the only forces we will encounter. We have not, for example, considered the buoyant force, air resistance, electricity, or magnetism. But having an understanding of the force of gravity, the normal force, the force of friction, tension, as well as understanding interaction diagrams and free body diagrams will go quite far in helping you understand and solve physics problems.